Now we come towards dispersive power of the prism. That is the magnitude of dispersion, means that how much angle is there between the two lights. So dispersive power of the prism, like omega is representing the dispersive power. It is delta V minus delta R divided by delta Y, where delta Y stands for deviation of yellow light. We can remember like this, that yellow light has wavelength which is more than 5000 angstrom units. Normally, sometimes it is taken as 5500 angstrom units. But if it is orange light, it will be still more, and its mean value is about 5800 angstrom units. So now, omega is calculated by function, that is delta V minus delta R divided by delta Y. And that is equal to NV minus NR divided by NY minus 1. And in numerator and denominator, A will cancel off. NV stands for refractive index for the violet light, NR stands for the refractive index for the red light, and NY stands for the refractive index of yellow light. So after all calculation, omega can be written as, that is NV minus N, that is NV minus mu V, NR minus mu R, NY minus mu Y. So mu Y means the refractive index of yellow light. Well, delta Y is the deviation angle for yellow color. Omega is equal to NV minus NR, that is refractive index for the violet minus refractive index of the red divided by refractive index of yellow light minus 1. Now we come towards the deviation without dispersion. That is, dispersion will not be there, but deviation will be there. This is how we have to go through. Now first of all, we take a yellow light, that is the mean ray. Yellow emergent through the combination of prism of different materials. So prism is not necessarily made up of only glass. It can be made up of glass and flint, or it is glass and quartz. So now we consider the yellow emergent through the combination of a prism of different material will be the parallel to the incident ray, but other emerging rays of different colors are not parallel to each other. So prism angle 2 divided by prism angle 1, that is equal to A2 by A1, then refractive index 1 for violet minus refractive index 1 for red divided by refractive index 2 for violet minus refractive index 2 for red. Well, now we come towards application of the prism. Prism angle of prism is 10 degrees. The refractive index for red and violet being given. That is, for red and violet, the value of NR and NV is given. That is, mu R or mu V is given. We are finding here that for red color, the deviation is 1.51, and for violet, it is 1.52. What is the dispersive power of that prism? So, these are 4 options given. To solve this question, we have to use the formula for the dispersive power of the prism. The dispersive power of the prism in terms of 2 colors, that is mu V minus mu R divided by mu Y minus 1, where mu V stands for refractive index of violet minus refractive index of red divided by refractive index of yellow minus 1. Now, the values of mu V and mu R are given, so we can find the value for mu Y. So, mu V plus mu R divided by 2, that gives the value of mu Y. That is the average value of refractive index of the yellow light, which is found to be 1.515 after computing the values. Now we have to estimate omega. For omega, we will compute the formula. So, according to the formula which is mentioned above, we have to compute the values and the final result for omega, that is the dispersive power of prism, that will become 0.019, and that is C option will be correct. Now we come to the second application. The prism angle and the refractive index for prism 60 degrees and 1.414. This is the refractive index for a prism of 60 degrees. Now we have to find the angle of minimum deviation. Now four options are being given. One of them is 15 degrees, the other is 30 degrees, the third one is 45 degrees, and the fourth one is 60 degrees. So we have to calculate the value that for which particular this minimum deviation will take place. Again, we use the formula of the refractive index, that is sine A plus delta m by 2 over sine 30, because it is given here that prism angle and refractive index of prism for 60 degrees. So mu is given to us, that is 1.414, and it is sine A plus d by 2 divided by sine A by 2. Angle is 60 degrees, we divide by 2, it will become 30 degrees. So in the denominator, it should be sine 30, and in the numerator, it should be sine 60 plus delta m by 2. The unknown part in this whole equation is delta m. Sine 30 we can compute as 1 over 2, and then we make calculations for delta m. So, after calculations by putting the values, we will find one of the value we get as 0.707, that is sine 45 degrees, which is normally 1 over root 2. So, if we multiply the number by root 2 and divide by root 2, it becomes root 2 over 2. And root 2 can be taken as 1.414, and when it is divided by 2, it will become 0.707. So, after calculations, we find that delta m comes to be 30 degrees. Now, for the next question, the refractive angle of the prism 60 degrees. That is, the value of A is given, that is 60 degrees. What is the angle of incidence for the minimum deviation? The refractive index of the material of prism is root 2. Root 2 stands for 1.414. Now, for minimum deviation, R is equal to A by 2, or that will be 30 degrees. Now, by using the Snell's law, that is mu is equal to sine I over sine R, and refractive index is being given root 2. So, root 2 is equal to sine I over sine 30. Now, sine 30 can be taken as 1 over 2. So, 2 will come in the numerator. So, we will get an equation, that is root 2 is equal to 2 sine I. So, now from this, we will get the value sine I is equal to 1 over 2 into root 2. Now, root 2, when we say, we multiply the whole number by root 2 and divide by 2. So, that will become 2 over 2 root 2. 2 will cancel off, and sine I will become 1 over root 2. Now, if sine I is 1 over root 2, obviously the angle will be 45 degrees. So, sine I will be taken as sine 45 degrees. And from both sides, we will find I will be equal to 45 degrees. So, our question was, what is the angle of incidence for the minimum deviation? And it is calculated as I is equal to 45 degrees.